Hi guys, welcome back to another great episode of the Linux channel. In this episode I'm going to discuss and I'm going to show you how you can generate spanning tree protocol packets or HTTP packets in short using via Linux raw socket programming. In my previous episodes I have shot and discussed earlier about generating OSPF packets and VoIP SIP packets, but the difference is in that case both of them are IPv4 packets. In the case of SIP packets it is a UDP packet, whereas in a case like OSPF it is actually an IP and then OSPF header. In this case it is relatively different. It's a pure layer 2 slow protocol one of the layer 2 slow protocol packet. So HTTP packets are relatively, it has less code in terms of generating via raw socket program. At the same time you just need to use it's a destination MAC address as a Ethernet multicast address. That's it. So let me just take you guys to my desktop and let me just walk you through the code. In case you are an admin or in case you are a hacker and not a programmer, you can just skip the source code part and you can just download my source code and you can just go through my instructions and compile it and execute your demo, and then you can just do necessary modifications and you can just use it in your field in terms of debugging something, or in case you want to hack something and figure out something happening in your network. So let's go to my desktop guys and let me just show you a quick code walk and a demo. Hi guys, welcome to my desktop guys. As you can see here this is my source code, which is http.c. so let me just open this file in a text editor. Yeah, as you can see here this is the raw socket code which I have written, and it is relatively quite small compared to my other few episodes which I shot before, which is about generation of SIP packets via raw sockets and OSPF packets with raw sockets. The reason is these are IPv4 packets and you need to do all the checksums and other stuff, and that kind of inflates the code, whereas in this case it is very much short compared to that. So let me just do a quick code walk, and you can see here this is the main part, and in the main API you can see the buffer which is HTTP. This contains the entire packet bytes, so which means the entire layer 2 header as well as its HTTP packet bytes as such. So essentially what happens is the first 6 bytes are the destination MAC and then the source MAC and so on as such. So since it is a layer 2 slow protocol, its destination MAC is a Ethernet multicast MAC address which is 0180 and C2 and followed by 000000. So this is a layer 2 slow protocol multicast MAC address as such. So, and then followed by which I am using this API which is create socket. I have already discussed about this API in my other 2 episodes, but in case you are watching this video for the first time, I'm just going to do a quick code walk. So the create socket, you can just ignore these constructs. So I'm just essentially creating a raw socket sock_fp file descriptor. So using these parameters, which is sock_raw and Ethernet protocol type all. So with this the socket file descriptor is generated, and then we need to do this bind system call. But before doing the bind system call, we need to know the interface index. So each interface in the kernel space will have an interface index actually. So most probably loopback interface will have index as 0 and then followed by which each 0 may have 1, 2 and so on as such. So we need to get the index of the interface. So what we are doing is using a system call, IOCTL system call, we are passing this command. This you can consider almost like a command as such. So this is actually a get command. You can see here it is system IOCTL get command. G stands for get, and the command what it needs is interface index as such. So with this API call, we are getting the interface index, which is populated over here, and then with the interface index we can do a successful bind call. So this is what is happening, guys. So once create socket is successfully executed, we'll get a sock_fd file descriptor, which is populated, and with this we can finally do a write system call. So with this the packet will be sent across as well. So you can see here I am passing this HTTP buffer, and then I am passing this size. So for now you can ignore this magic number. This is actually a bad way of doing a program, but since it is a very small program, you can just ignore about any sort of coding practices as such. So as I said earlier, the code is quite straightforward. Instead of using unsigned char, I am using this typedef. This is something which I just love about doing this way instead of using unsigned char. Actually, this doesn't look something which is easy to follow, is what I feel. So I just use always these kind of typedefs, so that you can directly understand the HTTP buffer is of the type unsigned char, which is nothing but it's a buffer which is of type byte as such. So let me just compile this code, guys, and let me just do a quick demo. So gcc -o http.c. As you can see, it has got compiled, and in this case before executing, you should notice it takes the command line argument as the interface of the NIC card. So sudo /http is 0. So just before executing this, we can start Wireshark, sudo Wireshark. So we can capture is0 interface, and we can execute this code. Let me just stop the packet capture. Yeah, as you can see here, it has generated the HTTP packet. It's a legitimate HTTP packet. In case if you are looking for any sort of customization, please change your source MAC ID according to the MAC ID of your interface. So in this case, I have not done that. It is kind of wrong way of doing the things, but in case if you are interested in terms of changing your source MAC ID, you can just directly edit these 6 bytes over here as such, because the first 6 bytes are your destination MAC address, which it is not supposed to be changed because it is a Ethernet multicached address. It is not any MAC address of a real physical device or hardware in your lab as such. Whereas the next 6 bytes is your source MAC address. You can just change it in case if you are interested something the MAC address of your port. But in this case, I just left it. Still it is generating the packet. So it is a kind of you can assume it's a sample HTTP packet, and the entire packet is generated. The entire frame is legitimate. So every time we see entire data link layer and the packet contents, you should call it as a frame, so that it's a kind of legitimate frame, as you can see here. So this is how you can generate a legitimate HTTP frame using Linux raw socket C programming. And in case if you want to generate any other HTTP packet, you can replace these bytes, and then you can replace its size accordingly. So guys, what I'm going to do is I'm going to upload this code in Google Drive, and then I'm going to share its link in YouTube description, so that you can download, and you can also compile, and you can test it in your lab or in your premises. So that's all, guys, for this episode. I hope you guys liked watching this video. Please do subscribe to this channel, guys, and please do hit the like button in case if you like this video. Thank you. Have a nice day.